Did you hear about the politician who made the campaign promise that if he was elected, everyone would have an above average income? So anyways, we're going to be looking at, in this case, medians instead of averages. So below is some data from TEA showing the average SAT scores for several high schools in Central Texas. This is from 2016. And Cedar Ridge, where I teach, is number 13 on the list. Does that mean it's the 13th best? Well, no, that's because this list is in ascending order of score. Sad to say, for IHS, they have the lowest score, and the highest score is the Lhasa High School system. So, Cedar Ridge's average score is higher than what percent of the high schools? Well, what we would do is take the total number of schools below that, so 13, so there are 12, out of the total number of high schools that I sampled here, and there are 27. So in this sample, Cedar Ridge is in the 44.4 percentile. So that's what we call that. See how I have the percent there? This describes the percentage of the data that is below the value. Okay, now what percentile is Round Rock High School in? Well, on this list, they are ranked 17th. There are 16 schools below them out of 27, so they're in the 59.3 percentile on the data. Now, one of the most common mistakes that happens is if you're looking at like class rank or something at school, people say, oh, are you in the top 10%? Or if you're trying to get into UT, is it the top 6% for automatic admission? Well, the top 6% is not the 6th percentile. It's actually the 94th percentile, because percentile goes from all the data below it, not what's above it. So what's so special about the score 1460 in this data set? Well, hopefully you'll remember from one of our earlier lessons, that's 0.14 out of 27. That's right in the middle. It is the median. Now, we just talked about percentiles, we talked about medians. Now we're going to talk about quartiles. So Q1 represents quartile 1. What percentile do you think this should be? Well, quartile is like a quarter, and a quarter represents 25%, so it should be the 25th percentile. You can also look at it as the median of the lower half of the data set, not including the median for the entire data set. So looking at the lower half of the data set, not including this one, there are 13 schools in the lower half, all right? So first half of data is before 0.14 right here. The median of the first 13th data points would be the 7th data point. So that would be LHS with a score of 1217. So that's 0.7 in our data set. Q3 is similar. It's the third quartile, and that is 3/4, which is 75%. So where's Q3? We're going to look at the top half of the data, which means above high school 14. So second half of data. The median of the last 13 data points is going to be this 21st data point right here. So Q3 is 0.21 with a value of 1563. What about Q2? Where's Q2? Remember, Q2 is the 50th percentile, so guess what that is? That's the median. So normally you won't see Q2, instead you're going to see median. Now, box and whisker plot is one way to really nicely display these important numbers. The inner box describes the middle 50% of data from Q1 to Q3. The line in the middle of the box represents, there's Q1 to Q3. The line in the middle of the box represents the median, so there's the median. The two segments sticking out from each end represent the top 25%, bottom and top. So there's the bottom, there's the top 25% of data. The first segment is going to start at the minimum, and then it should end at the maximum. Now, these 5 numbers on this box, there's your max, 1, 2, 3, 4, 5. These 5 numbers, which you need to construct a basic box and whisker plot, is known as the 5-number summary. Okay, so there's another important thing we need to know about this, which is called the interquartile range, or it's the width of the central box. So if it's from here to here, I can find the width by subtracting Q1 from Q3. Now let's go ahead and take a look at the data we have here. What is the 5-number summary? Well, we've already kind of derived all that. We said the min is easy to pick out. It's 955. We already talked about Q1. We already talked about the median and Q3. And the max is right there at 1971. Here is a box and whisker plot that was created using this data. So you can see there's the min at 955, there's 1217, here's the median, and Q3 and the max representing those numbers. Sometimes you can just write the numbers on it. Notice that not all the boxes are equal. So you're going, wait, 25% of the data here and 25% of the data here, but this is clearly narrower. So what does that mean? It just means that the data is more tightly packed, that we actually have a lot of scores from 1460 to 1563. In fact, if you look above the median here, here are the scores: 1463, 1505, 1508, 1535, 1549, 1553. So they're not even 100 apart. Now, if I look at this long whisker here, why is it so spread out? Well, okay, so going above that, 1563, so we get 1589, 1608, 1653, and now we're really starting to jump, 1733, jump almost another 100, 1824, and jump about 150 to Losses average, which was 1971. Oh, come on. So the data, we would describe this as roughly symmetric. If I wanted to say what the shape of the data is, personally, I like to have a histogram and a box and whisker plot. The box and whisker really helps me with symmetry. The histogram kind of helps me also with the symmetry and looking for gaps and things like that. So the data is roughly symmetric. Notice the average and the median, remember that's also known as the mean, are not that far apart. So we're, you got some ways you can go on it. You can say, oh, well, that's kind of tight there, but it's roughly symmetric, okay? Now, sometimes some points are really far away from the rest of the group. We call these outliers. So how do we know if a point is an outlier? Well, we actually have a rule for it. We take that IQR, which is the width of the box, and if anything's further away than 1.5 box widths, so we'll take it there, if it's higher or lower than the box, then we basically call it an outlier. So 1.5 IQR. For low outliers, it's going to be, remember the box starts at Q1, so we're going to take that Q1 value and then subtract 1.5 box widths from it. Okay. For high outliers, it's basically the same idea, but now we go to the high end of the box, which is Q3, and add 1.5 box widths. Remember, box width is IQR. So let's go ahead and look at that low point, 955. Is that one an outlier? Well, I went ahead and listed all the data again, just to the 5-number summary, so I can figure out the IQR. IQR would be Q3, which is there, minus Q1. So it's 346. I'm going to take this, multiply it by 1.5, and I have to subtract it from Q1. Q1 is 1217. So it's 1217 minus 1.5 of the IQR, which is 698. So a point has to be smaller than 698 to be an outlier. 955 is bigger. It is not an outlier. All right. Now let's take that high point, 1971. Is that an outlier? Well, I'm going to do the same thing, but instead of subtracting 1.5 IQR, I'm going to add 1.5 IQR to Q3, the top of the box, and I get 2081. So since our highest point is less than that, although it's not that far away from it, it is not considered an outlier. It has to be larger than 2081. Now, how do we draw a box plot when there are outliers? So I have this set of data, and yes, there will be an outlier. First of all, to get the 5-number summary, I'm going to show you how to do it here by hand again, roughly. But remember, if you put this in a calculator or a ClassPad, it will give you the 5-number summary in the report, and I'll show you an example of that. Okay, so looking at this, I went ahead and rearranged them in order. Then I found the middle spot. So the middle spot, 77.5, came from right there, in between 77 and 78. Then I take this first half of the data, and I look for the middle spot there. Now, you'll notice 66 wasn't there, but that's because there were 2 equal sets here. And this 77 is in the first half of the data. So these become my two middle points, all right? And my two middle points, I have to average between them, so I get 66. For the top half, I'm going to get the same thing. But this time it's between 89 and 89. Well, the average of 89 and 89 is 89, so that's Q3. Are there any outliers? So first of all, we need to find IQR, which is Q3 minus Q1, and we get 23. For the lower, I'm going to subtract 1.5 23s from Q1, so I get 31.5. Are there any points less than 31.5? Well, yes, there are. That 15 is. Now we calculate the upper boundary, and I get 123.5, and there are no points higher than that. 15 is lower than 31.5. There's nothing higher than that. That's our only outlier. So when we have our box and whisker plot here, this is the 15. And what point does that represent? That actually represents the 60 here. So let's go ahead and put the points on it. Here's 60 is not part of the 5-number summary because remember, the 5-number summary starts with the min. So sometimes the whisker won't end on the min or the max, and that's when we have outliers, if you draw it with outliers. If I had extended this whisker all this way, then it would be, that would be hitting the min for the 5-number summary. But it also, the advantage of showing outliers is you might be tempted to think that if I had a whisker going all this way, that maybe there were a lot of people that scored really low, when in reality, there was only one person that scored below a 60, which I think I'll have to help them with some tutoring, which I did, because we're some actual geometry quiz data scores. Then my Q1 is here at the edge of the box at 66. There's my median. And here's my Q3 and my max. Since there's no high outliers, you don't see any points to the right. Now let's compare the box plots for the test scores for two of my AP statistics classes. We'll start with center, so we're doing CUS. The median test score for the first class is about 80, and you can see for the second class it's considerably lower at 70. There are no outliers in either class, so I have the box plot turned on, so outliers would be marked with a little X or a dot. Unfortunately, we can't see gaps on a box plot, so we can't speak to that. If we had like a histogram or some other dot plot or other display, we could check that for gaps. In terms of symmetry, we're just going off the box plots. Again, having a histogram plotted would make this easier, or a dot plot. But I'm going to guess this one looks pretty roughly symmetric. This one is almost symmetric, but I'm going to say it's skewed to the right. Again, I'd be a little more sure of the shape if I had had a histogram drawn here as well. Then finally, the spread. And for box plots, we use IQR. We could also talk about the range. So IQR for the first class is at 22 points. If I wanted to do the range, you can see it goes from 100 down to about 55, so that's 45 points. For the second class, the IQR starting at Q1 here to Q3 here is 20 points. If I did the whole range, it looks like it goes from 49 to 100, so the range in this case would be 51 points. Again, if you have the chance to have both a box plot and a histogram, that'll make it a lot easier to check for unusual features and shape.